Hello everyone, Maros 10 was just released, and in this video I will walk you through the key features in this latest version. So the first feature would be yields. Since different feedstocks may produce different product yields, accurate yield modeling helps align production with market demand. Now, what is yield in Maros? So it allows the definition of products emerging from a process unit and their nominal product ratio. So as an example, for the finishing unit, we can define the yield to have the first would be naphtha with a yield ratio of 80, and the next product would be waste with a yield ratio of 20. So we have defined the ratio that will be coming out from the finishing unit as the products. Right, so what we'd like to do next is to connect the naphtha export node to the stream from the finishing unit. Likewise for the waste. So what we are doing here is essentially defining a relationship between the raw material coming into the finishing unit and the products emerging from it with yields. Now, different feedstocks may have different cost and availability, and prioritizing feeds ensures that the most cost-effective and efficient feed are used first. Hence, we have included feed priority in this release. Now, when a node has two or more feeds, the priorities defined for each feed will determine the quantity and ratio of each feed stream that is used. Now, for this example here, processing unit, we have feed 1 and feed 2, and what we have defined is that feed 1 will be the primary feed followed by feed 2. Should a user want to have an equal priority feed, this can be configured by changing the feed number on feed 2 to 1. So with that, you have set up a balanced relationship between feed 1 and feed 2, and this ratio will be kept with the fluctuations that may occur between feed 1 and feed 2. Normally closed nodes in petrochemical plants is an important feature because it enhances the accuracy of system reliability, availability, and risk assessments. Right, many petrochemical plants or refinery have equipment, pipelines, or process paths that may remain closed under normal operations, but may open under specific conditions. For example, maintenance, emergency, or process upsets. Hence, we have included this in the release. We have a node called off-spec product, and what we'll do is we'll configure this node to be normally closed, right? So there will be no off-spec coming out from the buffer tank, but what will happen is should an event triggers it, or buffer level triggers the opening of this node. So first of all, we need to set up the node by selecting properties and click normally closed. So when you have defined the node to be normally closed, the next step is to define the opening conditions. So in this scenario, what I'd like to do is to say, should the tank exceed 60% of its volume, then we will open this normally closed node. Yeah. So the level control will add a buffer level management, and the action will be open. And what it will do is to open the normally closed node when the tank exceeds 60 and close when the tank falls below 50. And the targeted node for this will be the off-spec product. Okay, so nodes can be opened by triggering from an event, whether it's a scheduled, unscheduled, or conditional events, or as what we have shown earlier, we triggered the opening of the node with buffer level. Now, the next thing that you may notice that we have included as part of the release is divergent flow capabilities, right? In downstream processes, and what we have seen and noticed is that flows can be really complex, right? A single feed stream splits into multiple paths, feeding different process units or product streams, and then it gets converged and diverged. So there are many different flow paths for a stream to happen. So what we'll do is to introduce a divergent flow capability so that our users can model this complex flow. So what we like to do here is to connect the product tree to the NAFTA node, right? So you can see, the flow has become complex, complicated with the introduction of this stream. So we have both convergent and divergent flow in this model. Last but not least is blending. Blending is a critical operation in petrochemical plants where multiple feedstocks, intermediates, or final products are combined to meet quality, costs, or operational requirements. Hence, we have included these in Maros 10. So what we have done earlier is to combine both feed tree and NAFTA together. And to illustrate how blending is done, we will then select the NAFTA node here. And what we can do is to predefine the feed so that they have a blending ratio. So we will do 30 and 20, for example. So once we have done that, what you may notice is there is a additional icons here, which indicates that a blending operation has been set up. Now, our software can also model dynamic adjustments to blending ratio in response to flow changes in the input streams, whether it's product tree or the NAFTA stream, right? So this can be set up as well. To learn more about Maros 10, please visit the Knowledge Center, review the release notes, or explore the help file for your areas of interest. Thank you for watching. If you have any questions or would like to know more, please email us digital@dmv.com. Thank you.